Hi guys, this is Miss Scott here, and today we're going to talk about symmetry. So our EQ for today is when does a figure have line symmetry and or rotational symmetry? Alright, so we need to talk about what those two things mean here. So the first thing is line symmetry. And line symmetry is simply a reflection that maps onto itself. All right. And what I mean by that is like if we made a vertical line right here through this figure. So this vertical line would mean, if you notice, it's the same exact shape on the left and the right of that line. Okay, so this is the line of symmetry, or in other words, the mirror. You can think of it as like a mirror line that cuts images in half. All right, so this would be the line of symmetry here. This figure has one line of symmetry because there's only one line that we can draw through that word mirror and makes it the same on the left and the right. All right. Rotational symmetry is kind of similar, but instead it's a rotation that maps onto itself. Oof, that's kind of hard to read, isn't it? Let's just go with a regular pen here. That is cool looking, but a little bit hard to read. So we'll just do plain old blue. So it's a rotation that maps onto itself. All right, so if we look at this word here, the word symmetry up above has rotational symmetry. The center of symmetry is simply the fixed point. So it's the fixed point of rotation. All right, so if we look here, right smack dab in the middle on this M, this vertical, almost vertical line, that would be our center of rotation. And if you rotate this word 180 degrees and tip it upside down, it's going to look the same upside down and right side up. So this figure has 180 degrees rotational symmetry. All right. Now let's look at translational symmetry. If you remember, another word for translation is a shift. So this is an image that shifts onto itself. All right. So we'll look at a couple of examples of that in a moment here. All right. And then glide reflectional symmetry means it does two things. It shifts, then it reflects onto itself. Okay, so let's look at some examples right down below here. This is actually an example of translational symmetry, because if you notice, this square with this slash through it shifts to the right, and it's the same thing here, and shifts again to the right, and it's the same thing here. All right. Same with these leaves here, but this is a glide reflection. So what happens is this leaf shifts this way. So let's make this smaller here. So that leaf shifts to the right, so it shifts this way, and then it reflects upside down. And then this leaf shifts to the right and reflects upside down. This leaf shifts and reflects, and then it shifts and reflects. So that would be a glide reflection. All right, let's look at a few more examples. So now we're going to talk about these with some specific examples. If we look at example 1, we're trying to figure out what kind of symmetries this has. And a lot of times figures have more than one. So the first thing I notice is that if I draw a line right down the middle, it would be the same on the left and the right. And I can also do that through the middle horizontally. Now this one actually has two others hidden in here. If I make this diagonal line here and this diagonal line here, I've got another couple lines of reflection. So this has reflectional symmetry. It has four lines of symmetry. And a lot of the time, if a figure has lines of symmetry, it usually has rotational symmetry also. Not always, but very often. So what we could do, if we know it has 4 lines of symmetry, if we take 360 degrees and divide it by 4, that means we would get 90 degrees rotational symmetry. All right, so you could take 360 and divide it by the number of lines of symmetry to get the rotational symmetry. Okay, let's look at another example here. In this figure, I notice I could draw a line right through here. Let's try that again a little bit better. And it would be the same on the left and the right of that line. So this one has 1 line of symmetry. Okay, and if we take 360 degrees and divide it by 1, I mean, technically, sure, you could say it has 360 degree rotational symmetry, but every figure has 360 degrees rotational symmetry, because if you take something and turn it around completely of 360 degree turn, it's going to look the same either way. So typically, we don't usually say something has 360 degrees rotational symmetry. Just everything does, so it doesn't make sense to say that about every single object. All right, so now we have our next example. There is no line symmetry. So, because notice these pieces are curved, and if we would try to draw a straight line, like for example through here, they're not the same on the left and the right of that line. So it does not have any line symmetry. Okay, that's not the case here. All right, but that's okay. It does have rotational symmetry. So notice there are 1, 2, 3, 4, 5, 6 pieces to this figure. So if we take 360 degrees and divide it among those 6 identical pieces, that would mean this has 60 degree rotational symmetry. All right, so sometimes figures can have rotational symmetry without having any line symmetry. Okay, in our next example, we've got a lot of symmetry in this snowflake here. So we could draw a line right here. We could draw a line right here. We could draw a line here. So there's 3 lines of symmetry, but then we could also do the in-betweens. So like from here to here, and from here to here, and from here to here. So notice we have 6 lines of symmetry here. So if it has 6 lines of symmetry, automatically we could take 360 degrees divided by 6, and we'd get 60 degree rotational symmetry. All right, so that one's got quite a bit of symmetry going on there as well. Okay, so now we're going to kind of work backwards. We're going to be given the symmetries, and we're going to see if we can come up with a figure that works for that description. All right, so that's what we're doing down in these 2 examples. All right, so we're going to sketch a hexagon with only 1 line of symmetry. So I know when we're thinking about a hexagon, we're probably thinking kind of the general shape like this. But if we draw that, well, we'd have 1, 2, 3, that did not go through where I wanted, 3, 4, 5, 6. So a regular hexagon has 6 lines of symmetry. We only want 1. So it's probably going to have to be a concave hexagon, which is a thing. All right, so here's one side. Here's 2 sides. 3 sides, 4 sides, 5 sides, and 6 sides. So I know that's a very strange looking hexagon, but it is a hexagon. And I should probably make sure this is going to go through where it should. All right, so it's got 6 sides. And notice if I drew this line right through here, it would have exactly 1 line of symmetry. So it did have to have 6 sides, but it couldn't be a regular hexagon. Then this right here would be that 1 line of symmetry. All right, so it can have a line of symmetry if it's this type of hexagon here. And there might be more ways to do that. That's just the way that came to me. Okay, let's look at our next example. A logo with 120-degree rotational symmetry. Well, to get 120 degrees, if we start with 360, what we would have to do is start with 360 degrees. And I'm thinking about what would I have to divide that by so I get 120 degrees. Well, 360 degrees divided by 3 is going to give me 120 degrees. So that means it's going to have, I could think of a logo that has 3 lines of symmetry. And I'm going to do my best to draw this here. You might start to notice what symbol I'm drawing once I get going here. So it's like that, and then it's got this, and I am no artist here, so if your picture doesn't look perfect, hey, guess what, we're kind of in the same boat here, because my picture is going to look a little bit off, but the main thing is that we get the main idea. This is supposed to be the Mitsubishi symbol. I'll be honest with you guys, when I did this in my notes, I Googled the Mitsubishi symbol and then I traced it. And as you can see, going freehand isn't really working out super awesome for me, but you get the main idea. We're going to just assume this is a nice, pretty Mitsubishi symbol. And it turns out that this symbol does have 120-degree rotational symmetry, because I could draw this line of symmetry here and this line of symmetry here. All right, let's try that again. All right, I am trying my best here. As you can see, I'm not quite the artist that some of you may be. All right, so now it's got these 3 lines of symmetry. If you can't draw this, hey, don't worry. I had a rough time too, so I'm going to make sure that I maybe write that that's the Mitsubishi symbol. And you might be able to find other types of logos that have 120-degree symbols, rotational symmetry. So if you can find another one, share it with me. I'd like to see what you come up with. Okay, so let's look at some more examples here. We're going to do some error analysis in these next 2 examples. So these 2 students made a couple of mistakes. So we're going to see if we can figure out what they are. In 7, they said this figure has 1 line of symmetry. Well, I can see the one like right down the middle of this bow tie, but I can also see that if I would cut this in half horizontally, it would still be the same on the top and the bottom. So their mistake is right here. It actually has 2 lines of symmetry. And I know that because if I would take 360 degrees and divide it by 2, I would get this 180-degree rotational symmetry that they're seeing. So, yeah, they had the wrong number of lines. All right, let's see what mistake they made in number 8. This figure has 1 line of symmetry. So I can see right here that if I cut this right down the middle, there would be my 1 line of symmetry. But if it's got 1 line of symmetry, we'd have to take 360 and divide it by 1. So it should actually have 360 degrees rotational symmetry, not 180 degrees. So that's their mistake here. Okay, let's look at the last couple of examples here. For some reason 12 kind of got cut off here. Let's see if we can fix that. Don't want to put a Y there. Oof. Deleted too much. I think that was a capital I. All right, so now we've got everything on one line here. All right, so the word mow. Let's see how many, what kind of symmetries that word has. Well, I do notice that it doesn't have any line symmetry, because if I draw a line like this, it's different on the top and the bottom. If I draw a line straight up and down, it's different on the left and the right. But I could turn that word around. So if I turn it upside down, so it has no line symmetry, but it does have 180 degrees rotational symmetry. Because if you turn the word mow upside down, it still says mow. Okay. The letter I, a capital I, if we draw a horizontal line, it's got that. We could draw a vertical line, which I know I'm kind of cutting right through it, but the letter I is actually got, it does have two lines of symmetry, as you can see from above there. And if it's got two lines of symmetry, 360 divided by 2 gives us 180 degrees rotational symmetry. Okay, the word Ohio, if you cut that straight through, notice it's the same on the top and the bottom. So it's got one line of symmetry. And if it's got one line of symmetry, I guess we could say it has 360 degrees rotational symmetry. Because if you turn anything upside down, it turns back into the same thing. All right, and the word pod. I don't think I can draw a line through it because it's going to be different on the top and the bottom. But it does have rotational symmetry. If you tip your paper over, the word pod still says pod, even if you tip it upside down. So even though there is no line symmetry, it does have 180 degree rotational symmetry. Okay. All right, we've got two more examples here, so just hang in there, guys. 13 says a regular triangle has how many lines of symmetry? Well, let's draw a regular triangle, and if you remember, regular means it's the same sides and same angles, so this would be an equilateral triangle is what they're talking about. So if we do our best here, this is just a sketch, so don't worry about making it perfect. Here's my equilateral triangle. And I'm going to try to do a little bit better job than that. All right, so here is my equilateral triangle. And we're going to figure out how many lines of symmetry that has. So I notice I could draw this line here, be 1. This line here would be 2. And lastly, this line here would be my third line of symmetry. So it does have 3 lines of symmetry. So if it has 3 lines of symmetry, if we take 360 degrees and divide it by 3, that means it has 120 degrees rotational symmetry. All right, now this last example has some woven baskets from Botswana, and we're going to figure out what kind of symmetries those baskets have. All right, so the first one actually has quite a bit. If I go from, if you notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points on that star, and we're going to assume that this is centered. Of course, it's just a little bit off kilter. I think it's just from the picture here. So that basket, if we connected all of those points, it would have 10 lines of symmetry. Whoops, I do not want a letter S. Whoop. Having some user error here. It's not working with me. All right. Okay, let's try this. Okay, there we go. Whew. I want to just erase this and write the word 10 lines of symmetry coming from those 10 points. So if it has 10 lines of symmetry, if we take 360 degrees divided by 10, that would give us 36 degrees rotational symmetry. Okay, and this next one, let's use green here. I've got on this star in the middle, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So if it's got 9 points, I could make 9 lines of symmetry through those points. And if we take our 360 degrees divided by 9, turns out you get 40 degrees of rotational symmetry. All right, let's plug right along here. This next basket, let's look at the points it has. 1, 2, 3, 4, 5, 6, 7. So it has 7 points, meaning it's got 7 lines of symmetry. And if you take 360 degrees and divide by 7, you get about 51.4 degrees for the rotational symmetry. All right, and last but not least, this figure here has 1, 2, 3, 4, 5, 6 petals. So it's got 6 lines of symmetry. And if you take 360 and divide it by 6, you're going to get 60 degree rotational symmetry. All right, so lots of symmetries all around you. We're just looking at some specific examples here. So if you guys have any questions, let me know. I'll be happy to help you out. Take care, and we'll see you guys next time.